Here's a problem on vertical circular motion. We have a ball on the end of a string and it makes 10 complete vertical revolutions in 6 seconds. Here's what we want to find. A, what is the tension in the string at the bottom of the circle? B, what is the tension in the string at the top of the circle? And C, what is the minimum velocity that the ball can travel to make it around the vertical circle? The first step in this problem is to find the speed of the ball as it moves in the vertical circle. Let's see how that can be done. Here's the circle, and we have radius r, which is 0.6 meters. So when it makes one revolution, the distance it travels is 2 pi r, the circumference of the circle. In this case, it's going 10 revolutions. So the distance is 10 times 2 pi r. The time it takes to do that is 6 seconds. Time equals 6 seconds. So the speed is distance over time, which is 10 times 2 pi r over 6. And let's put in what r is. R is 0.6. So it's 10 times 2 pi, 0.6, divided by 6. And that works out to be 2 pi. 2 pi meters per second. Or we could say 6.28 meters per second. That's the first step, is to get the velocity, the speed as it's going around. And we're going to assume it's constant speed as it goes around. Now, we want to find the tension at the bottom of the circle. So at the bottom of the circle, right here, so this is the string, and the things going like that. That's the speed, that's the velocity, and there's the ball. This is the center of the circle. So at the bottom of the circle, there are two forces acting. Force of gravity down, and the tension in the string up. And I'm going to draw this with the tension larger than the force of gravity, because it has to be. Since the acceleration is upward, the net force has to be upward. So let's do this. So this is the tension, and this is the force of gravity. So now we can write down, let's apply Newton's second law. Sum of forces in the y direction equals mass times acceleration in the y direction. Sum of forces y, so this is at the bottom. Sum of forces y equals tension. I'm going to assume up is positive because the acceleration is up. Tension minus force of gravity, and that equals mass times acceleration. And the acceleration is centripetal acceleration, which is v squared over r. So it equals mv squared over r. So therefore the tension is mv squared over r plus fg at the bottom of the circle. So if we put in our numbers, we're going to have 0.025 times this, 6.28 squared over 0.6 plus Fg is m times g, mg, 0.025 times 9.8. And that comes out to be 1.89 newtons. So that's our answer for the tension at the bottom. Okay. Now, shall I continue to the tension at the top? Or you want to try that on your own?
Could you go over C?
Well, I better do B first.
Okay.
Okay, let's do tension at the top. So at the top, what are the forces that we have? We have force of gravity down, and we also have the tension going down. They're both going down. So at the top, sum of forces in the y direction, and we'll say down is positive because that's the direction of the acceleration. So we have T plus Fg equals ma, and a is v squared over r, mv squared over r. So tension is mv squared over r minus Fg. And you can see the tension is lower at the top than it is at the bottom. At the bottom, we have to add Fg. At the top, we subtract Fg. Putting in the numbers, 0.025 times 6.28 squared over 0.6 minus mg, 0.025 times 9.8. And I believe that is equal to 1.4 Newton. Okay, so that's parts A and B. Okay, so what is the minimum velocity that the ball can travel to make it around the vertical circle? So now let's look at this thing. Let's write down the expression for the velocity. So at the bottom, we have mv squared over r equals t minus fg. T minus fg. This is at the bottom. And at the top, we have mv squared over r equals t plus fg. This is the top. So let's look at these two equations. So at the bottom, so we can make the velocity, the speed as large as we want just by increasing the tension, right? If we increase the tension, the speed can be as large as we want it to be, as long as the string doesn't break, both at the top and the bottom. To increase V, just increase the tension. So that will work. But what about the minimum speed? So large tension results in large speed. So how can we get a very small speed? We just use the smallest tension possible, which is 0. So what happens when we put the tension equal to 0? Well, look at the bottom. If tension equals 0, the minimum tension, we have mv squared over r equals negative fg. This doesn't make sense. We can have v squared as a positive number. So that can't equal a negative number. So it's not possible to have a tension of 0 at the bottom. At the bottom, T always has to be greater than the force of gravity, because we always need a net force going upwards at the bottom. So we can't put the minimum T at the bottom, but we can put the minimum T at the top. If we put T equals 0 at the top, what do we have? So let's try T equals 0. The minimum T, then we get mv squared over r equals fg. So this then is the condition for the minimum speed. We have the minimum tension. So that V is the minimum speed. So let's work out what it's going to be. Okay, Fg is just m times g. So this equals m times g. Now the m's cancel out. So this is an equal sign. M's cancel out. So we get V V squared equals RG, or V equals square root RG. So this is the minimum speed. If it goes at this speed, it can just go around the loop. If it's less than this speed, it's not going to make it around the loop. It's going to go up to the top, but then it's going to fall down. So the minimum speed, so this is minimum speed. Minimum speed. So we can work that out. V equals square root RG. So V minimum is square root RG, which is 0.6 square root 0.6 times 9.8. And that, what is that?
Could you elaborate more on why we have to look at the top instead of the bottom?
Yes. Let me just write down. That is 2.4 meters per second.
Okay.
2.4 meters per second. So why do we look at the top instead of the bottom? Okay. So, well, okay, so to make speed small, you have to make the tension small. So this lowest speed is going to have the lowest tension. And the lowest possible tension is 0. But we can't actually have a tension of 0 at the bottom because we must have T greater than Fg at the bottom. It can't be 0. We have to have a net force going upwards at the bottom. But we can let T be 0 at the top. So you let this T equal 0, and we have mv squared over r equals Fg, and then we solve it like that. So